Math 1143, Test 3 Review Sheet, Chapter 3 material. We're still in sections 3.3 and 3.4. We started graphing this logarithmic function last time, and because it's a base 2 logarithm, I chose my x values strategically. They are powers of 2. So when x is 1/4, the base 2 logarithm of 1/4 is -2. So we get this point on the graph, 1/4 -2. When x is 1/2, the base 2 logarithm of 1/2 is -1, so we get this point. When x is 1, the base 2 logarithm of 1 is 0, so we get this point. And when x is 2, the base 2 logarithm of 2 is 1, because 2 to the first power is 1. And then I pick x to be 4. The base 2 logarithm of 4 is 2, so I get this point. So the graph looks roughly like this. The y-axis, which is the equation x equals 0, that's the vertical asymptote. Okay, to find the inverse, we have to find the inverse. So y equals log base 2 of x. Interchange x and y, so x equals log base 2 of y. And we can solve this for y just by converting this to its exponential equivalent. The base 2 raised to the exponent x equals y, so y equals 2 to the x is the inverse of y equals log base 2 of x. Okay, the next function, y equals log base 3 of x minus 1. Remember, arguments of logarithms are positive, so x minus 1 is greater than 0, or x is greater than 1. So the domain is all real numbers greater than 1. So that means we're going to have a vertical asymptote. I'll identify it at this stage this time. The vertical asymptote is the vertical line x equals 1. Okay, so we'll pick some x and y values. And since it's a base 3 logarithm, well, I'll pick x to be, how about 2? So when x is 2, 2 minus 1 is 1, and log base 3 of 1 is 0. And then I'll pick x to be 4. 4 minus 1 is 3, and log base 3 of 3 is 1. And then if I pick x to be 10, 10 minus 1 is 9, and log base 3 of 9 is 2, because 3 to the second is 9. And then I'll pick 1 and 1/3, or 4/3. When x is 4/3, 4/3 minus 1 is 1/3, and log base 3 of 1/3 is -1. So this will get us started. As noted, the vertical asymptote is x equals 1. And then we'll stretch this out a ways and mark these 1, 2, 3, 4, 5. I won't have room to find the inverse if I go too far. But oh well. Okay, so when x is 4/3, the y-coordinate is -1. So we have this point on the graph, 4/3 -1. When x is 2, the y-coordinate is 0, so we have our X intercept. When x is 4, the y-coordinate is 1, so 4, 1 is a point on the graph. When x is 10, the y-coordinate is 2. So this is just a rough sketch of that logarithmic function. Okay, and we'll use this space up here to find the inverse of this function. So y equals log base 3 of x minus 1. Then replace y with x, replace x with y, and then solve for y. So we can convert this base 3 logarithmic equation into its equivalent base 3 exponential equation. The base number 3 raised to the exponent x equals y minus 1. I'll just write that as y minus 1 equals 3 to the x. And then add 1 to both sides, so y equals 3 to the x plus 1. That is the inverse of y equals log base 3 of x minus 1. Okay, the last one here on this page, graph y equals the natural log of negative x plus 2. Okay, well, negative x has to be greater than 0. So that means x, the x value, or the domain, are the negative numbers. X is less than 0. So on this one, it might be useful to begin with y equals the natural log of x. So y equals the natural log of x looks like this, roughly. And so the graph of y equals the natural log of negative x is the reflection of y equals the natural log of x across the y-axis. So we can graph y equals the natural log of negative x by reflecting the graph of y equals the natural log of x across the y-axis. So it looks something like this. And then the plus 2, we just raise this, we shift the graph of this function 2 units up. So y equals the natural log of negative x plus 2. We shift that vertically up. So this point, which is negative 1, 0, gets shifted up to negative 1, 2. So negative 1, 2. And the vertical line x equals 0 is still the vertical asymptote. Okay, so we're supposed to find the x intercept, and so the y coordinate of the x intercept is 0. So we just replace y with 0 and solve this for x, and that will give us our x coordinate of our x intercept. Okay, so subtract 2 from both sides. We get negative 2 equals the natural log of negative x. And then we can convert this to its exponential equivalent. The base number e to the negative 2 equals negative x. We want to solve for x, so just multiply both sides by negative 1. We get x equals the negative of e to the negative 2. Or you could think of it as x equals the negative of 1 over e to the second, if you want. And that is clearly a negative number, the negative of 1 over e to the second. So the x-intercept is the ordered pair, negative 1 over e to the second, 0. Okay, now let's find the inverse. So we have y equals the natural log of negative x plus 2. Replace y with x. Replace x with y, and then solve for y. First, let's subtract 2 from both sides, so we get x minus 2 equals the natural log of negative y. Then convert this to its exponential equation equivalent. E to the x minus 2 equals negative y. I'll just write negative y equals e to the x minus 2. And then multiply both sides by negative 1, so we get y equals the negative of e to the x minus 2. This is the inverse of y equals the natural log of negative x plus 2. Okay, so that's kind of a messy page, but we'll move on to the last page for the sections 3.3 and 3.4. Okay, on this one, problem 4, simplify each expression by using the definition and properties of logarithms. Okay, so log base 5 of 100 minus log base 5 of 4. So if you like to put parentheses around the argument, you can. So here we'll apply the property of logarithms. Since we're subtracting a base 5 logarithm from another, we can write it as a single one if we divide 100 by 4. And 100 divided by 4 is 25. And log base 5 of 25 is 2, because 5 to the second equals 25. Okay, on this one, since we're adding two base 7 logarithms, we'll write it as the base 7 logarithm of 21 times 7/3. And then we'll do the arithmetic in the argument. 21 times 7/3 is, well, 21 divided by 3 is 7, and 7 times 7 is 49. And log base 7 of 49 is 2, because 7 to the second power equals 49. Then on this one, 10 raised to the log base 10 of 11, just using the definition of a logarithm, this simplifies to 11. And then we're subtracting 10 raised to the log base 10 of 9. That's the same as minus 9. And then we're adding 10 raised to the log base 10 of pi. Well, this just simplifies to pi. And then we can write 2 plus pi. That's the best we can do, 2 plus pi. Okay, in the next few exercises, we're going to compress each expression into a single logarithm with a coefficient of 1. So on this one, 2 times log base 2 of x minus 2, we write that as log base 2 of x minus 2 squared. And then minus, instead of minus 3 times log base 2 of x squared plus 5, we're going to write it as minus log base 2 of the quantity x squared plus 5 to the third. And then plus, this one doesn't change for now. But we can, the one that we're adding, we can multiply this argument by the argument of the other positive one. So in the numerator, we have x minus 2 squared times x. And in the denominator, since we're subtracting this one, in the argument, it's x squared plus 5 to the third. So that is what the logarithm compressed to a single logarithm looks like. Okay, on this one, first we'll distribute subtracting by multiplying by 3, so we get the natural log of x minus 3 times the natural log of x plus 1, and then minus 3 times the natural log of x to the second. And then this middle one, we move the 3 to the exponent, so it's minus the natural log of x plus 1 to the third. And then the same with this one. We get the natural log of x to the second to the third. And then we can write this as a single logarithm, the natural log in the numerator of x. And in the denominator, we have x plus 1 to the third times. And we'll simplify this one. X to the second to the third is just x to the sixth. So that is our single logarithm. And we'll expand this one, log base 3 of x squared minus 9, and then minus log base 3 of x plus 5. And we can expand this one a little bit more because x squared minus 9 is factorable. But we're about out of time, so I'll leave the rest of that for you to do.